In this question, we're asked to count the number of significant figures in several measurements. So what I've done is I've typed out the rules for significant figures down here. It might not be a bad idea to pause the video and write these down. Significant figures come up a lot in chemistry, so it is important to learn the rules. So, here are some rules for significant figures. First, significant figures apply to measurements. You can recognize a measurement by the presence of a unit. They're not applying to counted numbers, such as how many people have watched this video. That is not a measurement, that's just the number of people. Or defined conversions, such as 1 liter equals 1,000 milliliters. There's no significant figures in that, that's just a defined conversion. So not all numbers have significant figures, but measurements do. If you measure on a balance that something weighs 2.3 grams, that is a measurement, and it has significant figures. Now, once you've decided things are measurements, which these all are, which you can tell by the presence of the units, there are rules for different numbers. These rules are all non-zero numbers in a measurement are significant. So all non-zero numbers in a measurement are significant. So any digit other than 0 is a significant figure. Then zeros are significant if they are between two significant figures, sandwiched zeros. An example of this would be like 101 grams. This is 3 significant figures because the 0 is between the 1 and the 1. And the second case is they're after a significant figure and a decimal point. It doesn't matter if the sig fig or the decimal point comes first. So it's really about finding whether or not zeros are significant. And Alex is doing something that some books do and other books don't, which is putting a decimal point at the end of a number. In this case, they're doing that to make the more significant figures present. Another way of doing this would be to write it in scientific notation, which is technically probably a little bit more correct, but I do want to show you the way Alex does it. But that rule is not printed here. So here we have a number, 0.002400, and we want to know how many significant figures it is. So really what we're looking at is the zeros. None of these zeros are sandwiched between two significant figures. So we need to look for zeros that are after a significant figure. In this case, the first significant figure is 2, and after a decimal point. All of these zeros here are after a decimal point. This 0 is kind of like a cosmetic 0, and it's not after a significant figure or a decimal point. So in this case, the 2400, these zeros are both after a decimal point and a significant figure. It doesn't matter if the decimal point comes first or the significant figure comes first, so this is 4 significant figures. These leading zeros are only after a decimal point, and they're not after a significant figure, so therefore they are not significant in this number here. In the next example, we have negative 5.0 times 10 to the minus 2. This number is written in scientific notation. In scientific notation, this number must be between 1 and 9.9. Said another way, this is the only number that we look at in order to determine the number of significant figures. And because it must be between 1 and 9.9, any zeros in this number will be significant. So this has 2 significant figures because any number written here must be both after a number and a decimal point, because the number will always come before the decimal point because this number has to be between 1 and 9. In this case, we have the same thing, 9.0 times 10 to the minus 2. These are both significant. Any number written in the coefficient of scientific notation will be significant. In this case, it's a little bit arguable, but what Alex is getting at is that all of these numbers are significant by putting the decimal place here. And this doesn't exactly follow the rules that we have down here, but Alex believes that this is 1, 2, 3, 4, 5 significant figures. Another way to write this number as 5 significant figures, that's probably a little bit more correct, but this is okay, is 1.7900 times 10 to the 1, 2, 3, 4 kilograms. This is without a doubt 5 significant figures because in scientific notation all of these are significant. In this case, they're trying to write this number with 5 significant figures by putting the decimal point at the end. But again, it doesn't exactly follow these rules.